In the previous modules, we have seen what a patent is and how it is searched in databases. Now I will show you very quickly what data can be extracted using commercial software, and then what are the advanced techniques based on artificial intelligence to extract other data from patents in a much faster and more accurate way. The information contained in a patent document can be summarized in the timeline of the patent with all the dates from filing to granted, who are the inventors and applicants of the patent, if the patent was sold to other companies and when. The status of the patent procedure, whether it is dead or alive, has been lapsed, revoked, has expired, granted, or is recent and is still awaiting grant. Finally, what is worldwide distribution? What are the other documents that are part of the patent family, and in which countries of the world protection is also active? The types of analysis that can be done by reading and analyzing patent are research of the state of art. These are searches in which I have to find all patents similar or equal to a specific solution and prior to this solution. All these documents are essential to understand if my solution can be patented or not. Freedom to operate is similar to the previous search for priorities, but I have to find a series of dead documents that allow me not to patent, but to use myself my solution on the market, or a series of alive documents that block me from selling because they still have protection activate on a solution equal or similar to mine. Patent enhancement, where I already have a patent or patents, and I analyze both the state of art and the scientific literature to improve my solution and also make other patents. The portfolio study, where every company once a year must understand whether to contain paying patent maintenance fees or not, must understand how much the patent value are worth, the patent values of the companies. Patent intelligence is the fundamental analysis in which I go to extract strategic data from a pool of patents and study them to understand how the market is on a given technology or sector. Competitor intelligence is similar to patent intelligence, but oriented to the study of my competitors, what they are doing, how many patents they have. Finally, the patent round, when I know one or more patents that I want to use without having problems. So I have to study how they are written to understand how to bypass their protection. All the previous analyses are only partially automatable, but mainly require manual work. Databases like SpaceNet or Google Patent are free and are search engines only. There are a number of paid software, such as Clarivate, Thomson, or Orbit in this case, which in addition to being search engines are also graphical dashboard to display a series of data. Let's see, for example, how Orbit works. This is the user interface is similar to a SpaceNet with the drawing of the patent, a series. This is a pool of e-bike, but I can select all the pool and analyze them. You can see the dashboard, a merge of the all charts. I can select only one chart. For example, this is a status of the entire pool, the number of granted, lapsed, pending patent. I can also select a series of the chart based on the year, for example, publication or application or priority year. Also charts on assignee or applicant, the top applicant in the sector, statistical or by year. I can show values. Also, I can search the collaboration between applicants. In this case, I have this collaboration. Or by inventor, so the top inventors with the number of patents, by year, or co-inventorship in a patent. This is an example. This is the number of patent for this author, and this is the number of patent of co-inventorship between this author and this author. Or I can select charts on countries, for example, priority countries. Is the first filling country of a patent. In this case, I have many patents in China. Or legal status, the previous chart, alive, dead, and so on. Coming back to slide. When we look at a graph, however, we must consider some aspects and limits. Let us remember that patent procedures are long and the patent is public only 18 months after fillings. Therefore, on the graphs, we have an offset of 18 months given by this delay, but also by the delay of the database updates. Therefore, often the last 2 years should never be considered because they are not complete data. Second, we will always see a growing trend in patents, for example, in this case, even in old or legacy sector. For example, analogical camera is a growth sector also in this year because patents always have a psychological growth given by many factors. In some cases, we will have a falsification of data due to a very high number of documents, for example, Chinese documents. They are patents that have little value, but which, being many, can create noise in data analysis. Finally, always remember that you should never look at a single graph or single chart because the data analysis is based on crossing different data, even very different from each other, in search of evolutionary trend, innovation trend. I have never talked about technology so far. This is because the data that we can extract using these tools like Thomson or Orbit is only bibliographic and not technological. We have only CPC that are a high-level classification of a technology or industry sector. In this case, the class C is a chemistry, the class A human necessity, and so on. But these are classifications provided by patent office and are mainly used to divide the various patents to be examined among the examiner. They are not available and are not often updated. Furthermore, there are no CPCs on new technology. For example, there are not CPCs on software or IoT or digital twin and so on. We must therefore find another way to extract the technological information. That is the most important because it provides us with the real data we need to understand the innovation trends of our sector. We have to use artificial intelligence systems trained in the patent world. Artificial intelligence has several branches. One is machine learning, where I have to train a system for the recognition and classification of new data. As we can see in this slide, the two main branches of machine learning are supervised learning or supervised algorithm and unsupervised learning. Very quickly, I'll explain you the difference between the two learning types. The supervised system is based on a training set of data in which people have manually classified all the data, and these data are correct. They are precise and correct data with which I train all the system. The types and problems solved by a supervised algorithm are classification problems and regression problems. In classification problems, I have a limited number of starting classes, apple or cupcake, in this case, with which I train the system. When a new data enters, the system must classify it in one of the classes, apple or cupcake, based on the training it has received. In this case, this new data is a cupcake. In a regression problem, however, I have no classes, but the goal is to predict a precise and accurate and numerical result. We therefore have a continuous function, such in this case is a straight line, where the system, when a new datum enters, must assign a value based on the function to this new datum. The mathematical function derives from training set. In this case, the system must indicate the price of the house as output, and as input, it has the surface or many other parameters of the house. So this is the function line. The new data is, for example, this, and the system have to predict the value of this point. Unsupervised system, or the other hand, have a training set that is not analyzed and correct by people. There are just a series of unstructured data that the system must group into some sets called clusters. The goal of the algorithm is to understand the structure of the data and place them into the right cluster. The problems that an unsupervised algorithm solves are anomalous detection, where the system must find anomalous data inside all the data that is not part of a cluster, for example. Or clustering system, where from a series of data in input, the system must divide all the data into different clusters based on some parameters that it finds directly inside and automatically inside the first data. In this case, I separate these characters into two clusters. A new step in machine learning is called deep learning. Is a recent evolution from 2010. It is a newer system and is based on a neural network. The difference between classical machine learning and deep learning is in the structure. Machine learning is based on a tree structure called the decision tree, with accurate and differentiated phases, the first, second, and third level. Deep learning, on the other hand, has a neural network in the background that automatically does all the phases and we directly output the result. In particular, a neural network automatically extracts the technical features to be searched for in document, while the classic machine learning it had to be done in the training phase, either by the system or by a man, by a people. The application of machine learning are many. For example, automatic translation, virtual assistant like, for example, Alexa or Google Assistant, traffic prediction, web search like social network search, social network analysis, sentimental analysis, find online fraud like email anomaly detection, for example, email spam filtering, the image recognition, for example, the face recognition, and in this case, I have to search, and the main application for us is the text mining. For example, let's see how a patent is written. We have a bibliographic part which is only 5% of the text. In this 5%, all commercial software works to create the dashboard. Instead, we have to work on the text, which is 95% of the document. The number of data and technical information I can extract from this 95% is much greater than just bibliographic data. We use a machine learning system called text mining, which is based on the study of NLP or natural language process, where algorithms try to extract information directly from a natural text, a text written as a speech, for example. There are all tools that don't use NLP system, but use a vector approach. They are called word embedding, and they go to understand what are the words that appear next to a specific term. For in this case, the term is, for example, USA. The other words are the other countries. And I create the vector between these terms and these terms. They construct a series of multidimensional vectors from this term to the other words. The values of that are given to the vector depend on the spacing of the words. Obviously, it is a tool that is used on a very large number of documents to create a vector statistical approach, and not on a single document or a single sentence. Some examples of this approach are n-grams, where I search for compound words that can be 2, 3, or 4 or more, or until n words that are always close to each other. In this example, brown fox or fox jumped. I create a compound words and I show it. Another tools is called word2vec, where I always build vectors. I first create a word map of terms, even in a two-dimensional space for this in this case. And from this map, I can show the various vectors starting from a specific term and toward another terms. Are not synonyms, but are vectors approach. For example, king is not a synonym of man. The semantic approach, on the other hand, is different. It is called a contextual approach because it does not use vectors, and as in the previous cases, but analyzes the text to create accurate structures that can be navigated by a user. I take a text, a natural language text, and I analyze by system. It is analyzed by system. The first step is to split a sentence of the text, and then split the words of the sentence, called sentence breaking and tokenization. A word is called token. The system is trained to recognize the point where a sentence ends and subsequently where a word ends. The second step is to tag the various words, indicating that the type of tag. For example, I take from a semantic library the types of tag. In this case, I tag a single word with the related tag. For example, verb, auxiliary, noun, adjective. In this case, is adjective, auxiliary, verb. The next step is to create the network of dependencies between the various tags. There are dependencies that derive from the logical analysis of the text. For example, the object of a verb. In this case, is paper is the object of the verb reading. An experienced user, a skilled user, can browse through these dependencies and tags to find exactly the technological feature that he is looking for. However, we must always remember that the limitation of an artificial intelligence system. An AI system actually copies something that already exists, doesn't invent anything new. In this case, it reproduces the work of a person, but does it much faster and also more accurately. Sometimes solving a problem is very complex, and you have to teach the computer what is the common sense to solve this problem. For example, the classic approach of innovation called trial and error cannot be applied to an AI system because it is too difficult, it's too hard to teach to the system. AI systems need to be taught systematic innovation approaches because they only work very well when the problem to be solved is well defined. We must therefore only teach a simple and effective step-by-step approach to the AI system. All this system can therefore be applied to the patent world to carry out many types of searches, not based only on bibliographic data, but based on the extraction of data from the text. For example, we can do searches like inward or outward technology transfer, technology forecasting, find a new and innovative technology, find the technology landscaping, find the blue ocean. Blue ocean are the first technology in industry when no other technologies are the same in that industry or in that sector. Other searches are technological analysis of a competitor or competitors, market analysis, a freedom to operate and patent circumvention, a deep freedom to operate based on a technological feature. And I can search commercial or partners based on the same technological feature of my solution. To give some example, in a technological landscape on laser cutting of glass, I want to look for the types of laser and their statistical and time trend. I can identify two types of that interest me and analyze them. In this case, I analyze CO2 laser and YAG laser. All of these features are extracted from text and not search by using a specific query or specific keyword. Only for that technology, I go to see what type of glass I can cut. And I see, for example, that the CO2 laser also cut vacuum glass, while the YAG laser doesn't do it. I haven't vacuum glass in this laser type. I can't cut this vacuum glass. Into the technology transfer phase, I go to see which technologies have been imported from other sectors. For example, in this case, I have electrical bike. I see that at first they use the batteries coming from automotive sector, transport sector, and are very old in time. In the last year, the technology transfer is take the new batteries from electronic or mobile device sector and introduce them into the electric bike. Even the analysis of competitor can now be carried out at another level, a technological level. I can see what technologies that they use and not just how many patents they have. Also, I can see the market distribution, the economic power based on a specific technology, for example. In this example, I have the analysis of macrogrid, is a type of electrical grid, and I see the investment value of ABB in the world. I can do the same for other companies like Siemens, and I can compare the two pictures, the two data. Or I can compare two technologies, such in this case EZBT is a type of transistor, and thyristor are two different technologies that I can use into the distribution microgrid. I can use this. I can compare many technologies based on a single competitor, 2, 3, 4 competitor, or the whole pool. A further very important step is the analysis of the requirement that we can translate into finding the problems to be solved and the solution, advantage and disadvantage. Solution can be found by, for example, using parameters such as improve is one of a type of parameter, while problems using parameter like reduce, decrease. The final result can be this: the extraction of a solution, in this case in the word of IRDI, where I identify which are the most market parameters, such as improving the color, is the most important in this sector, and other small and more recent ones, such as improving air washability, is recent and is very small, related to the first technological improvement. Good. My presentation is over. I hope it was very interesting for you and useful for you. I hope I have given you the tools to be able to do patent search yourself and to understand what are the data that can be extracted from a patent. I thank you again for the invitation, and I greet you and thank you.